In this video, we can learn about the push-down automata, its tuples, and also the different moves that is possible based on an example that is being given. Okay, so as we have seen, push-down automata, it can be represented using the tuples q, sigma, gamma, del, q0, z0, f. So the new symbols that is added up here when compared to that of the finite automata is the stack symbols and initial start symbol of the stack. Initial stack start symbol. Okay, so z0 will be considered as the initial or the start stack symbol of the stack, and this gamma will be considered as the set of stack symbols that can be used in the problem. And also one more difference is there, that is related to the del function. The del function is defined as q cross sigma star cross gamma star, which gives q cross gamma star. So the transition function will be like, it will be taking the element from state symbol as well as the stack symbol, and the target it gives the target state as well as it can perform some operations on the stack also. So that is the meaning of this del function. Now just we can see the example or a scenario in which some transitions are given like this. So these are the transition functions, and some states are given. Input symbol sigma is 0. Input symbol sigma is given as A and B. Okay, sigma A and B, and gamma, the state symbols will be taken as 0 and 1. Okay, tape symbols will be 0 and stack symbols will be 0 1. Sigma input symbols will be AB. So sigma will be loaded in where the tape. Input tape will be having this sigma, stack will be having this gamma symbols, and the final state that is given as Q3. Initial state is Q0 itself, and for stack start symbol, it is given as 0 over here. So the stack will be having initially 0 in the top of the stack. The top of the stack, you will be having what? Initial start symbol of the stack will be having this 0. Okay, so this is the first scenario in which Q0 will be the initial state, 0 will be the initial stack symbol of the stack, and the inputs will be formed using this A and B. Input tape will be having some string based on this A and B. So we can see the transition that is given over here. Del of Q0 comma A comma 0. First transition you are taking, del of Q0 comma A comma 0. What is the right hand side it gives? It is giving Q1 comma 10 and Q3 comma epsilon. So two transitions it is being given. And first one is like first Q1 comma 10 means that from Q0 to Q1 state moves from Q0 to Q1, and also the stack is having 0 as the initial symbol inside the stack. Was top of the stack, if it is pointing to 0, then at that time if it reads A input symbol, then push this 1 onto the stack. So 1 will be pushed onto the stack when A is being encountered in the input tape. Okay, so Q0 state, if the state is in Q0 and the input read is A and the stack symbol, top stack symbol is 0, then either it will be moving to state Q1 or it will be moving to the state Q3. If it is moving to the state Q1, then one input symbol will, one stack symbol will be pushed onto the stack on top of the 0. So the current top symbol of the stack will be 1. Okay, so that is one operation that is defined over here. Then next is q3 comma epsilon. So if the state moves to q3, it can move to the state q3 also. If it is moving to the state q3, then what it does, it pops the current element from the stack. So two transitions it is being defined over here. If it is moving to the state q1, it has to push the one element, one stack symbol onto the stack, and if it is moving to the state q3, then it has to pop the element from the stack. It has to pop the element from the stack. So that is the case with first transition. Now say the next transition, q0 epsilon 0, q0 epsilon 0. So what is the meaning of that? Stack symbol is 0, top stack symbol is 0, input red is currently pointing to an empty cell, and now it is in the state q0 itself, which means the input is empty and the stack top is 0. In such case, what it does is it moves to the state q3 and pops the current element from the current top symbol from the stack. So epsilon in the right hand side, if it is given, means it means that to pop the current top symbol from the stack. Okay, so this performs the pop operation. Here push as well as pop will be done. Okay. Then third function, see the third function, q1 comma a comma 1. So now q1 state, if it is in q1, input red is a and the top stack symbol, if it is 1, then what it does, it pushes 1 onto the stack. Okay, 1 1 state is remained in the state q1 and pushes the 1 onto the stack. That is why it is given over here as 1 1. So here again it performs what? The push operation. Okay, state remains in the same state and push operation is being performed. So here when A is being encountered, it is pushed onto the stack. Some value, that is 1 is a value that is being pushed onto the stack. Now again from state q1, if B symbol is encountered and the current element of the stack, if it is 1, means what it does, it is moving to state q2 and epsilon. Epsilon means that it performs the pop operation. Okay, so what is the current symbol of the stack? It will be popped from the stack. So when B is being encountered and if 1 is in the top of the stack, means that will be popped from the stack. Again in q2 state, if B is encountered, again 1 is there in the stack, means it remains in the same state itself, but popping operation will be done. So in this function also a pop operation will be done. q2 state, if the stack is empty and the top of the stack, if it is a 0, then it moves to another state, a q3, and again epsilon is there, which means a pop operation is done. So these are the different operations which can be performed in this push down automata with the help of this stack. So this is just an example to see how the operations can be performed. Okay, so from this set of functions, you can understand that from state to q0, you are having transitions like using the input symbol A, and epsilon, you are having the transitions. But input symbols A is there, one more symbol is there, isn't it? That is B. But that transition is not being specified in the function. Q0, B and the stack symbol is not being specified. So which means that the current PDA, it is a non-deterministic PDA. What is non-deterministic finite automata? It is not for deterministic finite automata, you have to specify transitions for all the states using all the input symbols. But for non-deterministic finite automata, it is not necessary that all the states will be having transitions using all the input symbols. So here from Q0 state, using the input symbol B, a transition is not defined, which makes the automata as non-deterministic push-down automata. Okay. Also, you can say from the first function, Q0, when it encounters with the input symbol A, it is moving to state Q1 as well as Q3. So, for a single transition, there exist two different transitions. So, using the same input symbol, if there exists more than one transition, then also we can say that the PDA is a non-deterministic PDA. So these cases makes the given PDA to be as non-deterministic push-down automata. So for a push-down automata to be deterministic means it follows the same condition as that of the finite automata, like what it need to have a single transition using these input symbol, and also from all states using all the input symbols, at least one it should have a single transition. Okay. To make the PDA as deterministic. So now the current PDA that is given is a non-deterministic PDA. Now you have to see what is the functioning of the inputs, functioning of the automata does. What function does it do? So here you can see from the example that when A is encountered in the Q0 state, Q0 is the initial state. So when A is being encountered, it pushes, either it is pushing a symbol 1 onto the stack, moving the state to Q1. Okay. So here when A is encountered, to the stack symbol 1 is being pushed. If B is encountered, and if the current stack symbol, top stack symbol, if it is 1, means that element is popped from the stack. Okay. And so this is the main operation that is being performed. From initial state, when A is being encountered, it moves to state Q1 and pushes that element Q1 onto the stack. So when each time when A is being encountered, what it does, it is pushing one stack symbol onto the stack. And state also, it is changed to which symbol, state, Q1 state. From Q1 state, again if it encounters A, and the stack symbol, if it is 1, means again it is pushing 1 onto the stack. Push operation is being performed. So Q1 state is like, it will be seeing this input symbol A, and each time when it sees the input symbol A, it will be pushing 1 onto the stack. This happens till it sees the input symbol B. Now next transition function, what it does from Q1 state, when B symbol is encountered and the top stack is 1. Top of the stack, if it is 1, means what it does, it changes the state to Q2, which means that now A input symbol, it has read all the A input symbol. Now it has started reading the input symbol B that is formed in the string. So it changes the state to Q2, provided if the stack top symbol is 1, then pop the element. Pop operation is being performed. Pop the element from the stack. So if it is in state Q1 and B is encountered and current stack top is 1. Change the state to Q2, pop operation perform. So what is the purpose of Q2? Q2 will be like hereafter if any B is encountered and stack top if it is 1 means state remains as such and it pops the element, current top element from the stack. So top element it will be like 1. Okay, this continues till the tape encounters an empty cell. And Q2 state if it encounters the empty cell and if the stack top is the initial stack symbol, that is 0. Initial stack symbol was 0, that is given in the question itself. So if the initial stack symbol is being encountered, then it changes the state to Q3, pop that initial stack element also from the stack. Okay, that is also popped from the stack. So these are some of the operations that is being performed. So what is the language with these different functions? What do you think the language will be accepted by the push down automator? It helps in identifying the set of strings in which n number of phase followed with n number of B's. A raised to this A raised to n, B raised to n. So the string language will be satisfying the set of strings of the form A raised to n, B raised to n such that n value can be greater than or equal to 0. Okay, so here with the help of stack, it is able to match the occurrence of n occurrence of A with n occurrence of B. So each time when A is being encountered to the stack, initially it will be 0. So each time when A is encountered, it will be pushing one element onto the stack. So if A is 3 means 3 A's and 3 B's are there in the string. So what happens? Each time when A is being encountered, 1 is pushed onto the stack. So the resulting stack will be like this. And when it start encountering with B means what happens? Each one will be popped from the stack each time when B is being encountered. And towards the end you will be again encountering with the 0. And tape also it becomes empty. So using this function, what it does when tape is empty and stack top if it is 0, then it is shifting the state Q3 to epsilon. It is shifting to the state Q3 and pop the current, that is a 0 symbol from the stack, making the stack as empty. Now when you see the state change also, you can see that from initial state when the first input symbol is being read, that is A when it is being read, so it changes from Q0 to Q1. Then Q1 when it reads A, there won't be any change. Next state change happens when it reads the input symbol B. So Q1 is state changes to Q2 when it reads the input symbol B. Okay, and again Q2 also it won't change its state when it reads the input symbol B. It checks for the empty state and Q2 changes its state to Q3 only when it reads the input tape. That is, if the tape is empty, then only from Q2 it moves to the state Q3. So these are the different moves that can be written for different problems. So if any comparison is being done between the terminals, that is forming the string, then in such cases you have to insert some values to the stack. Else just with the state transitions alone you will be able to design the PDA. So keeping the previous theory in mind, we can try to define the functions, or we can try to define the rules for the PDA. Like for any language, L is equal to a raised to n, b raised to n, such that n value is greater than or equal to 0. What all are the operations to be performed if from Q0 state, when a symbol A is read, you have to insert 1 to the stack, and state also it gets changed to Q1, and Q1 state will be like if A is encountered, 1 will be pushed onto the stack with no change in the state, it remains in the state Q1 itself. And when does it change the state? From Q1 to Q2, state change happens when it encounters with the B input symbol. And when B input symbol is encountered, it changes to state Q2, and to the stack, what is the change done? You need to pop the element from the, pop the current top symbol from the stack. Then in the state Q2 will be designed such that when it encounters with a B, it remains in the state Q2 and pop operation will be performed. Okay, epsilon means the pop operation will be performed. And this happens till Q2 encounters with some epsilon, that is the empty cell of the input tape. And when Q2 encounters the empty cell, then it moves to the Q3 state and pop the symbol that is currently being encountered. That is, so that symbol from the stack will be like the start symbol or something like that, and it will be encountered, and it will be popped from the stack. So keeping this procedure in mind, you have to write the functions. So what is the first one? When from Q0 state, when input symbol A is encountered and the stack top, if it is 0, then what is the target state to which it goes? It moves to the state Q1, pushes 1 to the stack. Okay, so this can be given. And then next function is like del of Q1 comma A comma, what is the input symbol? Q1 state is like if it encounters with A again, and stack's top symbol, if it is 1, will be equal to, it remains in the state Q1, pushes again 1, like that. So this will be the new one and this one will be the old one. Okay, the previous stack symbol. So that is the case with Q1. Then next one, this case, del of Q1 when it encounters with the B, and stack symbol, if it is 1, then it moves to state Q2, and what operation will be performed? Pop operation will be performed. Then again del of Q1, next is Q2, isn't it? Q2. Del of Q2, again if it encounters with B, and stack top if it is 1, then again it remains in the state Q2 and pop operation will be performed. Del of Q2, if it encounters with epsilon and the stack top if it is 0, then what it happens? It moves to the state Q3, pop the current stack top, that is epsilon. So these what we have listed it out, you have entered here. You have to see whether anything is missed out. So here one more thing that you have to see is here n value is greater than or equal to 0. N value is greater than or equal to 0. So epsilon also can be an element of the language. Okay, language either it can be AB or it can be epsilon also. So the minimum string will be like L can accept epsilon, AB, A, B, B, like that it goes on. So in order to accept this epsilon, one more transition you have to include, that is del of q0 comma epsilon comma 0. Del of q0 comma epsilon comma 0, it has to move to the final state, isn't it? So as per the problem, we have defined that q3 is the final state. So move to the state final state and pop that stack symbol. So q3 comma epsilon. Okay, so with these functions, you will be able to define the language for this question. For this language, you will be able to define these rules. So based on the previous transition functions, you are having one more thing, and one more transition you have written. That is here del of del of q0 comma a comma 0 is equal to q1 comma. So two transitions were defined to make the PDA as NPDA. That is, here one more transition is defined, that is q3 comma epsilon. Okay, q3 comma epsilon, which means that initial state, from the initial state, if it encounters with A and if it is having the initial stack symbol as 0, then directly it will be moving to q3, which means q3 is the final state. So irrespective of this language a raised to n, b raised to n, it also says that it will be accepting the input string a alone also. That which means language will be accepting epsilon, a b, a b b, like that, a raised to n, b raised to n. Together with this, it also accepts what? A alone. That is, string A also will be accepted by the language. So, so the given transition, that is that we have discussed earlier, that given transition, it is having one more transition in addition, which defines the language in a different way, such that it will be accepting all the strings of the form a raised to n, b raised to n, union A. Okay, so this is the final answer for the given transition, that is that we have discussed. Okay, just go through the functions and see whether you are able to understand. We can see it with the help of an example also, that is processing the string. So to process the string, state, input, stack. So q0 state, input if it is taken as 3 A's and 3 B's, stack 0 initially if it is 0, q0 when it reads A and stack symbol is 0, q0 A is 0. Using the, you can just number the functions 1, 2, 3, 4, 5, 6. Okay. So using the second function, you can write it like the state changes to q1. remaining input to be read you can write over here. Then stack, you have to push this 1 onto the stack. So resulting stack will be this. So Q1 A1 next so what is the transition used? And here it has used the second transition. Then Q1 A1 third transition, using the third transition, where it goes Q1 pushes the element 1 onto the stack, so it remains in the state Q1, remaining input to be read, pushes 1 onto the stack. Again Q1 A1, so again it remains in the state Q, remaining Q1, remaining input to be read as BBB. 1 will be pushed onto the stack using transition 3 itself. Again Q1 B1. So here from Q1 state, if B1 using the fourth transition, Q1 B1, it moves to the state Q2. So Q2, remaining input is like to be read as BB, and what is the operation that is performed? That is pop operation. So pop the element, remaining stack symbol will be like 110, and again Q2 B1, again using the fourth transition, it remains in Q2 B1 using the fifth transition. Fifth transition, it remains in the state Q2 itself, remaining input to be read as B, pop the element from the stack, so resulting in 10. Again Q2 B1 remains in Q2 state, input epsilon becomes, and stack will be like it is having 0 using the fifth transition, that is popping the last element from the stack, not the last element, one element from the stack. Then again Q2 epsilon 0. So here the last transition, Q2 epsilon 0. So sixth transition, making use of that, it moves to Q3 state. Tape becomes empty, pop the stack also, so that also becomes empty. So we can see that it reached to the final state, emptying the tape as well as emptying the stack symbol. So this is the way you need to process the string, and the string is being accepted by reaching to the final state as well as making the stack as empty.